Wait, what? Astatine? I bet it's radioactive. It is. Astatine was the 85th element, unmetallic, also an halogen with 85 protons and 85 electrons with 125 neutrons. Astatine was discovered in 1940 by Dale Corson, Kenneth Mackenzie, and Emilio Segre with a density of 6.2 to 6.5 grams per centimeters cubed. Astatine has a melting point of 575 degrees Kelvin and a boiling point of 610 degrees Kelvin. Astatine has an atomic weight of 210 atomic mass units, and it was named after the Greek word, astatinos, which means unstable. This unstable halogen was once believed to be the rarest element on Earth. It wasn't until 3 years later, however, that astatine was found in nature. Since astatine is usually only found as a state of another heavier element in the process of radioactive decay, astatine is one of the rarest elements on Earth. Only up to 1 gram of astatine at a time has ever been discovered in nature. Astatine cannot be seen with the naked eye, since a large enough sample would immediately disintegrate due to its own radioactivity. There are 32 isotopes of astatine. All of them are radioactive, with the most stable being at 210, whose half-life is just over 8 hours. Only 5 of the isotopes even have half-lives longer than an hour. The isotope of astatine is the only one of astatine's isotopes with a commercial use, where it is used in the diagnosis of some diseases. Astatine is the rarest element, other than the transuranic elements, those with a higher atomic number than uranium. Astatine was once believed to be the rarest element on Earth, prior to the discovery of berkelium in 1949. Since that time less than 2 grams of the element have ever been produced. Since it is only released during the radioactive decay of other elements, it is estimated that there is no more than 28 grams of astatine on Earth at any time. Astatine has an important use in nuclear medicine, but it decays so quickly that it must be used within a matter of hours following production. Astatine concentrates in the thyroid and liver in a way similar to iodine, but it does not emit high-energy electrons like iodine does. Its short half-life makes it preferable to iodine for some treatments. Animal experiments show that astatine does far greater damage to cells in the thyroid than iodine does. But stay tuned for add-on.